In this session, we'll be talking about the definition of or and how to use or and in inequalities, especially when we talk about using inequalities in English, mathematics and reasoning, or any other application of the same in daily life. So let's start. Now, if you have already referred to my earlier session on inequalities, you would have come to know by now that the words or and in a certain sense are mutually exclusive to each other. Now, when I say exclusive to each other, the point that I'm trying to make here is the word and is a synonym to the word conjunction, which means together. Now, when you say together, let us understand this with the help of an example. If somebody says that Anant and Naveen are supposed to do this work together, Anant and Naveen, focus only on Anant and Naveen, are supposed to complete this work together. So what does this convey? Both of them together are supposed to complete this piece of work. So together. So when you're working together, there is a possibility, or there would be an intersection. Now, the moment you say intersection, what are we basically trying to convey? So, if there are two entities, Anant and Naveen being represented by B here, so it is A intersection B. Similarly, when we are talking about or, and if I use the same example that I had used earlier with respect to Anant and Naveen doing a piece of work or completing a piece of work, let me take an example by saying that Anant or Naveen will do this piece of work or complete this piece of work. Then what are we trying to convey? We are trying to say that Anant and Naveen in a certain sense are disjoint sets. So either Anant does it alone or Naveen does it alone is what we are trying to say. So they are disjoint to each other. Plus, at the same time, whether you do it alone or you do it together is not the point of consideration ultimately for the work to be completed. The work should get completed. So at least one of them should complete the work. So, or here symbolizes what? Exclusivity. Exclusive of. And when I am using the word exclusive here, then I should use the word inclusive in terms of and. So, and when I'm using intersection here, in that case, I'll be using the word union. So, Anant or Naveen being represented by B here is a union. So in a certain sense, you would say that and becomes a component of or. When I say component in mathematical terms, I could have said that and becomes a subset, which is a kind of a component of or an ingredient of or. Other way of explaining the same is or already has the and complement, the and ingredient in it. That is another way of understanding this. Okay, so this was the definition of and or, and now we will talk about how to use them effectively. So you would see that the first three cases that I have taken under the head of simple cases are simple inequalities. Now when we say simple inequalities, here I am basically referring to linear inequalities. What are linear inequalities? In which we are talking about a simple thing. Simple here refers to single. A single variable x or a single power of x is being used here. So if I say x greater than 2 or x equal to 2 or I say x less than 2. Please mark the words being used, or, because all the three cases are exclusive. And if I combine them under two heads, let us say that what I'm trying to convey here now is, let us say that this is case A, this is case B, and if this is case C, A plus B is just like saying not C, which I have already discussed in my earlier session on inequalities. And if I'm discussing C, that means not A and B, which is just like saying not greater than, neither greater than, nor lesser than means what? Equal to. Okay, now let's come down to the compound cases. So you will see that the simple cases, if I simply take let's say the first case and the third case, and I use and or in between, the inequalities, they become compound. Why do they become compound? Because there are two or more inequalities being used together or exclusive to each other. And why do I say together? Because if I'm using an and in between, which means intersection, or I'm using or in between, which basically means union. Now, if I have understood this in principle, now it becomes very easy for me here refers to a learner. It becomes very easy for a learner to take this learning to the next level, given the fact that you have already seen the earlier or experienced the earlier stepping stones or the sessions on the same topic, which takes your learning to the next level. Okay, so now starting off with example 1, the compound case, wherein we are saying what? X is less than 2 and at the same time x is less than 3. And we know that and means intersection. Intersection means the common part. Another way to interpret. So now, if I do not want to draw the diagram, and if I want to come down to the crux of this discussion, and the crux here is, what is the common part to, let's say, A and B? If this is A, right, and if this is B, and we are looking for the common part, that means we are looking for the intersection. So X, if I say A intersection B, what would be the intersection part here? A only? Yes, so you have the answer. X is less than B. And as of now, we are not talking about drawing the diagram to infer. We are just reasoning it out with the help of logic or syllogisms, and we are coming down to this conclusion. Second, now if we have to be quick at this, x is less than 2, and at the same time we are saying x should be greater than 3. Now we are talking about x less than 2, that means we are talking about all the values till 2 but not inclusive of 2, and at the same time we are finding out the intersection between A, which is x is less than 2, and B, which is x is greater than 3. The answer is no such value, empty set or phi. Empty set, not possible, because these are contradicting each other. Third point, x is greater than 2 and x is less than 3. Okay, we are talking about x being greater than 2, and at the same time we are talking about x being less than 3, and we are looking for intersection. So this is the intersection. That means we are basically talking about all the values which lie between. Mark the words being used, between. So when we are talking about inequalities, and now if we are drawing a line, so let us say line wherein the extremities, we know that arrow means that the extremities are excluded. So the word between means what? Exclusive, excluded. X is between A and B. Right? Let me talk about the fourth case. So the fourth case basically talks about, let's say this says x is greater than 2 and x is greater than 3. So I hope it is fairly simple now, and you can immediately come down to a conclusion which says x is greater than 3. Let me talk about the fifth case now. Now 5th, 6th, 7th, 8th, you will come across cases wherein we are using OR. So we are saying x is less than 2 or x is less than 3. In a certain sense, this is A and this is B, and we are talking about A union B, right? So, and we know that these are disjoint cases. So and we know that by definition, we know by now that intersection means the common part. In that case, exclusive becomes either uncommon. The uncommon part, either we say this or we say whole of it. The word uncommon would be slightly harsh to use here because as we discussed, that OR has the AND component already included in that. So we cannot say that the word OR is an antonym to the word AND. So the word uncommon would be harsh and slightly wrong to be used here. On the contrary, we would say whole, or we would use a word like disjoint. So once I know that I'm supposed to join two things together, which is x less than 2 and x less than 3, it is always the superior which represents, which is the whole part of it, which means x is less than 3. See, this comes as a contrast to the first case, wherein it was always the lesser between the two, and here it is always the greater between the two. The greater here refers to a bigger set. Okay, let's take the sixth example here, the sixth case, which says x is less than 2 or x is greater than 3. Now these are disjoint cases, you have nothing in common. This will be taken as it is. Taken as it is means what? You will just represent this by a union in between. So this remains as it is. You will say that x is a variable which takes all the values till 2 and all the values greater than 3 and extends till plus infinity. This is how you're going to represent it. Point number 7, case number 7, which talks about x is greater than 2 or x is less than 3. Now here also you would see that we are here referring to what? We are referring to all the values which are greater than 2, and at the same time we are referring to all the values which are lesser than 3. So if I put a union sign in between, which is just like saying x is greater than 2, union x is less than 3. So which is the bigger set here? Now there is no bigger set except for the fact that now when you're saying that x takes all the values till 3 and at the same time you are saying x takes all the values starting from 2 and ends on a 3, that means you are basically talking about you're taking all the real values, because we discussed that x is a real number. I hope you would have understood this case. The last case here, which refers to x is greater than 2 or x is greater than 3. Now when we are saying x is greater than 2 or x is greater than 3, which is a bigger set here? The bigger set is the set of those values which cover the larger count of values, which is x is greater than 2. So you'll be able to see the difference that you would have got in terms of the answers if you are using an or an and. So be very cautious of it and be very wary of it when you're using the word or and in daily life, so that what to say of in theory, when you're using these words in daily life also, you do not err. You do not commit a mistake. Last, now this was the interpretation of a line. Let me take a ray here. Now if I say this is a ray, which you know that this is a ray, and this starts from C and ends on D. How will I represent this? I will represent this as x is greater than or equal to C and less than D, because dot means included and the arrow means till that point which excludes D. And just for the sake of writing here, I am writing this as this. We represented, this is a line, this is the representation of a line, and then the inequality connotation, and then trying to convert this in English. So pictorial representation of line is, this is what it is. The pictorial representation of line being converted into the inequality format, and then using English to interpret the same. The same we did for ray, wherein we will say that when I say greater than or equal to, that means the connotation here is from C to D, but excluding D. Please remember this. The last but not the least, so line we have done. The only thing that remains here is line segment. So this pictorial representation being done in red color is nothing but a line segment that I am discussing. And when I am talking about this line segment, and if I say that this starts from E and this ends on F, how will I represent this in an inequality format? This is x is greater than or equal to E and less than or equal to F, is what we are seeing. Please mark the words being used. X is greater than or equal to E and less than or equal to F, which makes this case similar to this case that we had discussed, this case number 3. The only difference here being we had just taken the inequality, we had not considered the equality part. And then, as discussed earlier, what is the interpretation of greater than or equal to from E to F? The moment you say from something to something, that means both the endpoints are included. Right? The last thing here, taking the entire discussion to a final level, wherein I will take one case here. I'll just take one case from here out of these 8 cases, so that you are able to understand that case graphically. And I feel that the most difficult case here, as discussed earlier, is the 7th case. So if I had to understand this thing graphically, and if I'm able to understand this, maybe as an assignment, please do it for the remaining 7 cases, which are all the cases from 1 to 8 excluding the 7th case. Now in this case, what are we talking about? We are talking about, let's say this is 0, this is 1, this is 2, and this is 3. We are saying x is greater than 2. So we represent this with the help of a line, and at the same time we are saying x is less than 3. And we know that now if I say this is, let's say this was A, set A values, and this is the values arising from set B. So the values arising from set A, so you have some point of intersection in between, which is why, if you would recall my earlier statement, which now you will be able to understand, that the word or has the word and at most included in it. Now I'm trying to be more technical here. So the word or already has the word and in it, either implicitly or explicitly. So this becomes the point of intersection for both the lines, which symbolizes the and part is already there. So let's just shade this for the sake of understanding. And then let us see that this extends from a minus infinity to a plus infinity. And it includes all the values starting from minus infinity, comes till 3 and then goes on further towards plus infinity, which is why we had represented it by, since we are discussing real numbers, or another way of writing the same was x is greater than minus infinity and less than plus infinity. You can take further examples if you feel that you have some queries, you have some questions, so you can put it in the comment section so that we can address your queries.